Hey, did you know that recently we've picked up several exciting hints about life beyond Earth? Strange gases in distant atmospheres, important molecules swirling around newborn stars, ideas that cosmic radiation could spark life beneath frozen worlds. Okay, sure, it's not a cryptid message from some galaxy with ET saying hello, but taken together, these clues point to something unexpected. Not only could there be life on other worlds, but it might be a lot more common than we ever thought. But first, let's explain how we learn what's out there in deep space. When scientists say, "Hey look, we found something hundreds of light years away," that doesn't mean they pointed a telescope and zoomed in on a planet like with a mouse scroll on Google Maps. Most planets are invisible, drowned out by their star's light. Instead, researchers study starlight as it filters through a planet's air. Different gases absorb specific colors, leaving a unique chemical fingerprint. Decode the missing colors, and congratulations, you know what's in the air. And that's what the James Webb Space Telescope is built for. The James Webb is incredibly impressive. NASA claims that the telescope is so precise it could detect the heat signature of a bumblebee on the Moon from Earth, if the bee stayed still long enough. That's not even the best part. Unlike regular telescopes that see visible light, JWST sees in infrared. It doesn't usually show us those far-off planets directly. Most of the time, it reads the starlight that filters through their air. Thanks to its giant gold mirror and super-cold instruments, it can pick up faint traces of certain gases from hundreds of light years away. Maybe it won't show us little green men, but if they're out there, we might learn what they're breathing. Which is what happened recently when researchers looked at K2 18b, a planet that's about 120 light-years away. They picked up signs of a gas called dimethyl sulfide. Never heard of DMS? That's fair. But here on Earth, DMS is made almost entirely by life, specifically tiny ocean creatures like plankton. So, if you're detecting DMS here, you're probably standing near seawater with a high-tech measuring device. The whole DMS discovery sounds huge, but hold on. It's a bit early to celebrate. This doesn't mean there's a bikini bottom on K2. The signal is faint, and scientists are still debating if it's even real. And even if it is real, life isn't the only explanation. Lab experiments in 2024 suggested DMS might also form without biology under certain exoplanet-like conditions. We've even detected it in comets and interstellar clouds, places where no one expects living plankton. Still, the evidence is strong. Additional studies have shown that the odds of this signal being just a random mistake are less than 0.5%. That's solid by scientific standards, a real, okay, let's take this seriously moment. Experts say that the key question is, what kind of atmosphere does K2-18b actually have? If it's deep and heavy, abiotic chemistry could explain DMS just fine. But if it's shallower and has a liquid ocean underneath, then biology might be the best and most exciting explanation we've got. Either way, the outcome is huge. Scientists are either seeing the first signs of extraterrestrial life or discovering a brand new kind of chemistry. But it gets better, because the next theory comes not from examining a planet, but from what's around a protostar called V883 Orionis, in a completely different part of the galaxy, located 1,300 light-years away. Scientists notice something special. The baby star is still forming, wrapped in a swirling cloud of gas and dust. And inside that dusty cloud, astronomers have found 17 complex organic molecules, the kind you find in biology textbooks. We're talking about molecules like glycolaldehyde and glycolanotril, which might sound like names for supervillains made of sugar, but they're actually precursors to stuff found in DNA and RNA. From what we already know, this is quite confusing. For a long time, scientists believed these molecules only formed later, after planets cooled, oceans appeared, and chemistry had time to simmer. Some even suggested they had been brought to Earth aboard comets and asteroids, forming in deep space and surviving the cosmic journey. This concept is called the panspermia theory, and is still debated. Regardless, it's unexpected to see pieces of the life puzzle floating around a half-built star. It's kind of like having flour and baking soda before the fire is even a thing. And it gets better. These molecules weren't destroyed by the radiation blasting out from the newborn star. In fact, some scientists think the radiation might have actually helped create or preserve them. So, what does that mean? It means that basic chemistry for life might not be rare at all. In other words, the recipe for life might be already baked into star systems before planets even appear. The ingredients don't have to be created later. They're already there, just waiting for the right planet to form in the right place at the right time. But what if that's not the case? What if life doesn't even need a star in order to exist? For decades, we believed the Goldilocks zone was the only place where life could happen. The perfect cozy location. If a planet is too close to its star, the oceans boil and you get something like Mercury or Venus. If it's too far, everything freezes and you have a giant ball of ice. However, the latest study suggests that deep underground, sunlight might not matter at all. A group of scientists ran computer models that suggested life could potentially exist in super dark, frozen places, similar to what's beneath the surface of Mars, on Europa, or rogue planets, all thanks to cosmic radiation. That's right, high-energy particles from deep space are constantly pelting planets and moons at nearly the speed of light. Normally, radiation is the bad guy. It mutates cells, damages DNA, and even fries spacecraft electronics. But in the right conditions, it might have different roles. Earth is protected from cosmic rays because it has a thick and awesome atmosphere. But on planets with thinner atmospheres, like Mars, these rays can reach the surface and possibly below ground. Cosmic rays hitting underground ice can split water into useful chemicals like hydrogen, oxygen, and other reactive stuff that might support microbes. Just enough to kickstart life. This led researchers to propose a cool new idea: the radiolytic habitable zone, a region where cosmic radiation is the main energy source driving chemistry underground. Simulations show that Enceladus, one of Saturn's moons, might be the best bet for life supported in this way. This really changes everything, because if life doesn't need warmth, sunlight, or even a star, then our idea of habitable may be way too narrow. Suddenly, there are way more worlds that could have life hidden away. Very primitive forms of life, because without sunlight, there's no photosynthesis, no plants, no food chains like we know them. The energy supply is just too small. So, as far as we know, complex life probably still needs a star. But simple life? Not necessarily. On Earth, some of the oldest and toughest organisms live off chemical energy deep underneath. Surviving without the sun, bacteria in caves, microbes beneath glaciers, and even weird life forms near boiling vents at the bottom of the sea. They might thrive by tapping into the chemistry around them. These are called chemoautotrophs, and they might be exactly the kind of life that's most common in the universe. We'll just have to wait and see. So, to recap, life might be floating in alien atmospheres, hiding in baby star clouds, or stuck deep underground, eating cosmic rays and radioactive things. If all of these theories turn out to be correct, it's not just exciting, it's revolutionary. Life doesn't need ideal conditions. It adapts, it endures, and maybe it's everywhere. Not to mention that there still might be some complex life forms out there. We just can't see them. Or maybe they're staying silent, like the universe is a dark forest. Space is just that huge. By the time the James Webb Space Telescope captures something, it might already be gone. Until ET sends us that message. If we don't want to feel alone in the universe, even a microscopic cell counts.
The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler, NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. Let's be koi, K-O-I, shall we? This wonderful planet is in the constellation Cygnus, and why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Our sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than the Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Ideally, we need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely that there will be at least some organisms there. KOI 57115.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees, which is slightly less than ours, 57 degrees. But it most likely feels warmer there, because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light years from Earth, which is about 18 quadrillion miles. Yup, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on the Earth. The more heat there is on the planet, the more comfortable it's to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1 1/2 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The resemblance is so striking that scientists believe that we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? What do you think they could look like? Very Earth-like planet, but with stronger gravity. If someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them, and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin, because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near the red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. You'll probably say, but won't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But, of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today it's just a red desert, and there is no life there, at least not as far as we know. But you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. It's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62z and Kepler 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62m is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we've talked about. Scientists believe that both 62e and 62f are sort of water worlds. Warm places mostly, or even completely, covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some. Think Hawaii, and a nightmare for others. Think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What is its composition? Density? One day, maybe we'll be able to answer these questions. And so, that's it for the super Earths. Of course, the original list is much longer, and you can go check it out on the internet. The best thing about all this is that these are the planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are a few of them have at least some form of life. But they're very, very far away, so we have no way to check it right now. Perhaps down the road, we'll find some cool creatures on many of them.
Well, NASA has just dropped the craziest news ever. They've found the clearest evidence yet that life might have once existed on Mars. So, is that what you'd see if you travel there? Well, let's imagine, shall we? The world around you is red, darker than Earth. There's a dust storm on the horizon. Suddenly, you spot a bizarre creature that makes your blood run cold. It's way taller than you, with long, creepy-looking arms and legs. Its skin is orange, and its eyes are huge. They look like some kind of shiny lenses. Come to think of it, it all makes sense. Gravity on Mars is 38% weaker than on our planet. That's why this creature has grown to be so tall. You know, when astronauts go to space, they tend to grow up to 2 inches, all because the reduced gravity makes the fluid between their vertebrae expand. As for the creature's unusually colored skin, this is protection against solar radiation. Mars doesn't have a global magnetic field. There's nothing to protect the planet from radiation. And the locals' bodies probably had to switch their pigmentation from melanin to carotenoids, the same pigments that give oranges, carrots, and tomatoes their bright color. As for those big, beautiful eyes, they help the creature perceive the light of our now-distant sun much better than regular human eyes. Now, if this is the story you wanted to hear, I'm sorry to disappoint you, because the life forms we've discovered on Mars are very different, and still, for scientists, they are no less exciting. Last year, the Perseverance rover, the most expensive off-roading robot ever, found a dried-up riverbed covered in weird, rusty circles they're calling leopard spots. According to a scientist from NASA, these spots might be leftovers from ancient life forms that lived there billions of years ago. And now, experts think they might know what those tiny Martian critters could have looked like. Once again, we're not speaking about creatures with eyes or tentacles here. Mars is a wild place that gets roasted during the day, then drops to minus 225 degrees Fahrenheit at night. There's low gravity and nasty radiation there, so anything living out there would have been microscopic, bacteria-level small. If, and it's a big if, something more complex ever evolved on the red planet, it would have needed insane superpowers to survive those conditions. Anyway, while cruising around an area called Bright Angel, Perseverance spotted those leopard spots. Scientists call them reaction fronts, basically places where chemical stuff went down long ago. The rover found two minerals in these spots, vivianite and greigite. On Earth, vivianite shows up when organic stuff rots, and greigite is made by microbes, tiny living things. One of the scientists on the team said those minerals look exactly like the kind we find when microbes are involved here on Earth. In his words, this could be the most convincing evidence of life on Mars so far. Of course, there was still a chance these patterns had been made by non-living processes. Nature could have been doing its thing without any help from space germs. But after a year of tests and reviews, and probably a lot of coffee, the team says they're confident this could be a real biosignature. So, what would this Martian life even look like? You see, today, Jezero Crater, a big impact basin just north of Mars's equator, is basically just a dusty wasteland. But billions of years ago, that place was full of water, a real Martian pond. Scientists think that the crater back then had cold, water-rich spots that were perfect for little microbial life. Those microbes could have munched on stuff like carbon, sulfur, and phosphorus in the rocks, and the minerals they produced could be what we see today as those leopard spots. Now, even though the surface conditions on Mars were insane, with freezing temps and all that radiation, microbes could still make it work, just barely surviving day to day. Experts point out that there was actually liquid water at that time, so it means the red planet was technically habitable. Now, since all we've got are these tiny traces, we can't say exactly what Martians look like or how they acted. But we can make some educated guesses by looking at Earth. We could compare the microbes from Mars with extremophile bacteria on our planet, those tough little guys living in salty lakes, deep underground, or in deserts so harsh even cacti wouldn't bother. Another question is, could anything bigger or fancier than microbes have ever evolved on Mars? Probably not. If those leopard spots are actually signs of life, scientists think microbes weren't just hanging out in one spot. They were likely all over the place. Perseverance is checking out ancient rocks beyond Jezero Crater to see if Mars had a bigger population. But here's one thing. Mars got harsh very fast. Life may have popped up on this planet around the same time as on Earth. But after about 1 billion years, the red planet started losing its atmosphere thanks to solar winds. That turned Mars into a freezing, dry wasteland. The extreme cold, radiation from the sun, and lack of water would have made it super tough for anything bigger than microbes to survive there. Complex life, like animals, took another 3 billion years to appear on Earth, and conditions on our planet were way more pleasant. If anything more advanced ever showed up on Mars, it would have had to be like a superhero microbe with thick skin or an ability to hide underground to dodge UV rays and survive in freezing temperatures. It would have been living off whatever tiny puddles of water it could find, basically like desert lizards or those weird filter feeders you find near Earth's hydrothermal vents. Now, we might still need to wait before we meet a real Martian resident, but nothing can keep our imagination from wandering. So, how about we sneak a peek at what the inhabitants of other planets of the solar system would look like if they existed and were more complex than microbes? Now, if it was a creature from Jupiter, It would probably be something like a deep-sea tank bug with a thick armored shell, huge googly eyes, webbed claws, and gills. All those features would help it survive Jupiter's crazy high pressure, radiation, and endless liquid layers. Because on this planet, at first, everything is just clouds. But go deeper, and gas turns into a liquid ocean of metallic hydrogen. No wonder locals would need all the protection they could develop. Let's jump over to Saturn with its clouds, rings, and more clouds. This planet is so light it could literally float in a giant cosmic bathtub. Here you'd likely come across a giant space jellyfish. It'd float through thick fog with an umbrella-shaped body and long tentacles instead of arms. Saturn's pressure is huge, and having a skeleton would just get it squished. Floating and flopping around is the smartest survival hack here. Now we're going to visit the ice giants, Uranus and Neptune. Both planets are like cosmic slushies of ammonia, methane, and water. Boy. There's no solid ground anywhere, just icy oceans under thick atmospheres. Here, you might meet a stocky, muscled amphibian with stubby limbs, webbed fingers, and scaly skin. All because gravity on the ice giants is higher than on Earth, and the environment is freezing. Any creature living there would need short, strong limbs to survive crushing pressure, swim through icy oceans, and stay warm. Moving back to our neighborhood, the first stop is Mercury. The Sun here is so close, it looks 3 times bigger than on Earth. Temperatures swing from instant frostbite to literal oven. If anything could survive here, it'd probably have titanium skin. It would be smooth all over, and sunglass-like eyes would protect it from ultra-bright solar rays. The thing is, Mercury has almost zero atmosphere and intense sunlight. Anything living there would need a body capable of surviving heat and radiation without melting or burning out. Our final stop is Venus. The pressure there feels like you're a mile underwater. Volcanic eruptions are popping off all the time, and the air could melt lead. Tropical. And life forms here would be downgraded to a microscopic blob. No arms, no legs, and certainly no face. Venus is insanely hostile, crushing pressure, molten hot temperatures, and toxic gases. Only tiny microbial life could probably survive here. Given all that, I'll take Hawaii instead.
Dozens of spacecraft and hundreds of probes take off from Earth and head for our planet's twin sister, Venus. It's about the same size as the Earth and has around 80% of our planet's mass. The temperatures here are too high for humans, and it doesn't have the air we're used to breathing. But we went there because scientists recently found traces of phosphine gas, which suggests that life might be there. Phosphine comes from various microbes and bacteria, so humanity goes on this journey to discover this life. With our technology, a flight to Venus would take 3.5 to 6.5 months, but we finally made it. Spaceships are landing on the planet, and when the first humans come to the surface, they see heat-scorched deserts, lava lakes, and geysers of poisonous acid. And that's it. Scientists miscalculated the radio telescope data. Phosphine never existed on Venus. So we're going back to the rockets, and we're getting ready for a longer trip across our galaxy. The scientists believe that there's at least 36 civilizations in the Milky Way that are similar to ours. They could be living organisms completely different from us. They may have different bodies, different eyes. They may walk and talk in a very different way than we do. But an advanced civilization has several criteria: technological progress and the use of developed communication between individuals. So, these civilizations must explore space, build cities, and be able to communicate with each other as independent species. Let's look at our galaxy and find these civilized worlds. So, the Milky Way is a spiral of 100,000 light years from side to side. If a star is born at one end of it in a super powerful blast, the light from that event won't even reach the other end until 100,000 years later. There's about 100 billion stars, and near each of them, there may be worlds similar to our solar system. Let's try to find these habitable worlds using giant sieves. First, we look for stars that have a lot of iron. Such stars burn at the perfect temperature for the development of life. And the iron in the star system will help form the cores of planets that will be home to another civilization. We sift the Milky Way through our sieve. We see that there are too many stars that fit the description, so we need another filter. Now let's find stars that look like the Sun in this pile. The star must be about 100 times larger than the Earth and 333,000 times heavier. An important criterion is the age of the star. When a star gets old, it begins to expand and turns into a red giant. At this time, it can absorb the planets around it. The life of such a star can end with a huge blast that destroys everything around it. So the star we're looking for must be relatively young. Let's use our sieve again. There's fewer stars, but still that's a lot. Now let's focus on the planets. They should be in the habitable zone of the star. Not too close to a star because then the temperature would be too high for life to be born. And not too far away. Then the planet would just be an ice block with nothing living on it. The temperature of the planet must allow the water to remain liquid. Another filter is the age of the candidate planet. It takes time for an advanced civilization to develop. Based on the experience of Earth, scientists believe that it takes at least 4.5 billion years for any life form to evolve to the human level. So we're looking for planets similar to Earth or older. We use our sieve one last time, and voila, we have 36 worlds where an advanced civilization is possible. Scientists conducted this study and published it in April 2020, based on these very criteria. All that's left is to discover these civilizations and make the first contact. We can detect such a civilization by using radio waves that come from it. Suppose there's a planet A with primitive living organisms on it. Millions of years of evolution, and they'll become a civilization with advanced technology. Radio waves will be the way they communicate. Then the whole planet will emit radio waves like a star emits light. And here on Earth, we'll be able to pick up this signal with antennas pointed into space. But there's a problem with the distance between the planets. For example, planet A is 1,000 light years away from the Earth. When planet A starts emitting radio waves, these signals won't reach us until 10 centuries later. We learned to emit and receive radio waves in 1895. And if the civilization on planet A emitted a radio signal at the same time, we won't be able to pick up that signal until 2895. It'll be the same on planet A. We sent a message in the form of a radio signal into space in 1974. In this signal, we encoded our number system, human DNA, and information about our solar system. If there's an advanced civilization on planet A, they'll be able to receive this signal only in 2974. And we'd have to wait another millennium to get a response from them. Another problem with radio waves is that they don't look like a constant glow on the planet, but like a flare. Radio waves are only used at a certain stage of civilization. At first, it's the primary method of communication, but then we begin to use cell phones, cable TV, and fiber optics. And as technology advances further, our radio wave light begins to fade out. So we only have about 100 years of active radio use by civilization to find it. One day we caught a strange radio signal of an unknown origin. Its characteristics suggested that the signal was created artificially, perhaps by an outer space civilization or a passing starship. Further searches for this signal given no results, and this gave rise to many theories and arguments as to what it really was. It could have been a signal from Earth that reflected off a satellite flying through the sky, or it could have been the traces of a comet a few light years away. But let's assume it was a civilization from outer space, one of those 36 that probably exist. Now we need to make contact with them. So we throw our luggage into a rocket and head out in the direction of our suspected planet. Our rockets can fly at 17,600 miles per hour. That means a rocket could cross the entire United States in just 8 minutes. But even if an advanced civilization lived near our closest star, Proxima Centauri, it would take us about 73,000 years to get there. Even at the speed of light, it would take 4.2 years. So we need to solve the problem of space travel. Our scientists plan to reach about a quarter of the speed of light with a laser. A powerful laser beam from Earth will push a microscopic probe in the right direction. This probe could reach our destination in about 17 years. And in another 4 years, when the signal from it reaches Earth, we'll know if there's an advanced civilization. Another possibility for faster-than-light travel is the warp bubble spacecraft. The spacecraft would have to compress space in front of it and stretch it behind its tail. Then we'll be able to reach any point in the universe in literally a few seconds. But such travel remains a fantasy for us. Perhaps we can get to different corners of the universe through wormholes. They're shortcuts similar to tunnels, but there's one problem. These wormholes might be inside black holes. They're the most mysterious objects in the universe. They're so heavy that even light can't escape their trap. Our spaceships wouldn't stand the tension either. There's also a theory that Earth is unique because it was born under completely accidental circumstances. 4.5 billion years ago, our planet was a block of lava that began to cool and solidify, but its tranquility was broken by an asteroid the size of an entire planet flying by. The collision occurred at such an angle that the Earth was not completely destroyed, but part of the asteroid remained in our orbit. A heavy rock near our planet stabilized Earth's rotation, and the gravitational interaction with the giant debris caused our core to heat up. In addition, the asteroid brought a lot of water to Earth. Such a collision is extremely unlikely. It's like winning the lottery, many times in a row. But so far, we have no reason to believe life in outer space exists. Just as we have no reason to believe that there's no advanced civilizations in the universe, except for ours.
Look at this fascinating planet. It looks as if it's burning. It must be hotter on its surface than in the middle of Death Valley. The ground is parched, cut by giant cracks. There's not a drop of water in this boiling world. Now, it's the same planet, but it looks like a totally different place. Everything is frozen. The temperatures are so low, there isn't even a tiniest chance that life could survive on this planet. This bizarre world is called HD 20794d, and it's located 19.7 light-years away from Earth in the constellation Eridanus. This planet is a super-Earth. This term means that it is larger than Earth but smaller than such ice giants as Neptune. What makes this planet especially interesting is its unusual orbit, which moves it in and out of its star's habitable zone, the region where temperatures might allow liquid water to exist. Now, we haven't seen this unusual planet directly. Astronomers detected it by measuring tiny wobbles in its star using two powerful instruments, espresso and HARPS, located at telescopes in Chile. These instruments measure radial velocity, which is the small movement a star makes as a planet's gravity tugs on it. The larger the wobble, the more massive the planet. Later, astronomers analyzed the data and figured out that the planet in question has a mass around 6 times greater than Earth's. It orbits a star, which is slightly smaller and dimmer than our Sun. What makes this star unique is that it is bright enough to be seen with the unaided eye, unlike many other stars that host exoplanets. You won't be able to see them without a telescope. The star system has been observed for over 20 years. Astronomers have long suspected it had multiple planets. In 2011, scientists discovered 2 other super-Earths orbiting the star every 18.3 and 89.6 days, respectively. For some time, researchers thought they had found a third planet with an orbital period of 40 days. Later, they realized they had made a mistake. But recently, after reanalyzing years of data, astronomers have confirmed that the third planet does exist, and it's our extreme HD 20794d. A researcher from the University of Oxford played a key role in identifying the planet. He used a special computer algorithm called Yarara to separate the planet's weak signal from the background noise. It helped him confirm that the planet truly existed and was pretty unique. Unlike the planets in our solar system, which have mostly circular orbits, the newly discovered one follows a highly elliptical, stretched-out orbit. It takes 647 days to complete one trip around its star. That's just 40 days shorter than Mars's orbit around the Sun. At its furthest point, the planet is twice the Earth-Sun distance, which makes it an icy world far outside the habitable zone. At its closest point, it moves inward to 0.75 AU, where it enters the habitable zone, where liquid water might exist. This extreme movement creates truly bizarre seasons. For some part of its orbit, HD 20794d is frozen, like an icy wasteland. As it approaches its star, temperatures rise and ice likely melts, forming temporary oceans. The planet then experiences a short, scorching summer. It is so hot that the water on its surface might evaporate into the atmosphere. Shortly after, the planet moves away again. It triggers a gloomy fall with rains, followed by a deep freeze in winter. In other words, The planet switches between extreme cold and intense heat, which makes it a very unpredictable place for life. If any life forms exist there, they certainly need to adapt to dramatic changes in temperature and environment. Why does the planet follow such a mind-boggling orbit? It might be a leftover effect from events billions of years ago, when the planetary system was still forming. At some point, another large planet may have disturbed the orbit of our extraordinary friend. Another possible explanation is that a giant planet once existed in the system, and its gravity pushed HD 20794d into an elongated path. Later, this giant planet may have been ejected from the system, leaving the smaller planet in its current orbit. This theory makes sense because the two other planets in the system, B and C, have more normal circular orbits. The discovery of this planet is so exciting because it challenges what we know about habitable planets. Most planets in the habitable zone stay there permanently, but HD 20794d only passes through it. Scientists want to know if such a planet could still support life, even briefly. So future telescopes will study the atmosphere of this planet, looking for signs of water, gases, or even life. Another super-Earth that might have the right conditions for life orbits a star 137 light-years away. In space terms, this is considered relatively close. A light-year is around 6 trillion miles. The planet is called TOI 715b, and it's about 1.5 times the size of Earth. Unlike HD 20794d, it's permanently located in the habitable zone. Look, that's what astronomers think the planet might look like. TOI 715b orbits its star very quickly, completing a full orbit in just 19 days. But even though it's close to its star, it may not be extremely hot, all because its star is a red dwarf. That's a type of star that is smaller and cooler than our Sun. This means TOI 715b could have a milder temperature compared to other exoplanets that orbit closer to hotter stars. NASA discovered the planet using the Transiting Exoplanet Survey satellite. This space telescope finds planets by watching for small dips in a star's brightness, which happen when a planet passes in front of it. Since red dwarfs are smaller and dimmer than the Sun, planets passing in front of them are easier to detect. Astronomers are planning to study the planet further using the James Webb Space Telescope. This powerful telescope, located 1 million miles away from Earth, can analyze the atmospheres of distant planets. If TOI 715b has an atmosphere, JWST could help scientists determine what gases are present in it and whether such conditions could support liquid water or even life. One more promising world for our search for extraterrestrial life is an extremely dense super-Earth in the K2360 system. An international team of researchers from Japan and Europe has discovered this remarkable multi-planet system orbiting a Sun-like star located 750 light-years away. This system has 2 planets, including one of the densest rocky planets ever found. The K2360b is a rocky super-Earth, about 1.6 times the size of Earth, but with a mass 7.7 times greater. This makes it as dense as lead. The planet orbits its star incredibly fast, completing one full orbit in just 21 hours. It's the densest known ultra-short period planet with well-measured properties. As for its sibling, this is a much larger outer planet with at least 15 Earth masses. It takes 9.8 days to orbit its star. Sadly, since it does not pass in front of its star from our viewpoint, scientists cannot determine its exact size. The unusually dense planet might be the core of a much larger planet. Over time, intense radiation from its parent star may have blown away its outer layers, leaving behind only its dense, rocky core. So, in fact, This planet could show us what might happen to some planets that are too close to their stars. Astronomers think that the planet may have moved inward over time due to interactions with its larger companion planet. One possibility is high eccentricity migration, where a planet's orbit becomes highly stretched out due to gravitational interactions before gradually becoming more circular near the star. Another theory is that the planet's spin and axial tilt can cause its orbit to become more circular. Such planets are rare, and finding one with a massive outer companion can help scientists refine their theories about how planets form and evolve in extreme environments. With its help, we might also understand how rocky planets evolve and what happens to planets that get too close to their stars.
So, astronomers have just announced that they might have found signs of possible life on a planet outside our solar system. Wow! This distant world is called K2-18b, and it sits about 124 light-years away in the Leo constellation. So, what life are we talking about? Little green men? Octopus-like tentacled creatures? Well, not exactly. First things first, let's define what life is. It's what distinguishes animals and plants from inorganic matter, like the ability to grow, reproduce, and change. Now, what do we need to support life? If what comes to your mind is water, bingo! Scientists have the feeling that K2-18b might be covered in oceans, and if it's so, it can support tiny forms of life like microbes. A team of researchers from the UK and the US used the James Webb Space Telescope to look at the planet's atmosphere. They found hints of two very special chemicals. On Earth, only living things can produce those, and the living things I'm talking about are mostly tiny ocean plants called phytoplankton. So, basically, this planet might indeed host life in the form of algae. Now, of course, scientists still need more proof before getting too excited. We should keep in mind that it's possible that those chemicals were made by something we don't understand yet, not necessarily by living things. But still. K2-18b is a big boy. It's more than 8 times heavier than Earth and about 2.5 times larger. So what makes it even more interesting is that it's located in the Goldilocks zone around its star. That means it's not too hot and not too cold there, just right for the existence of liquid water, which is highly important for life, as we know it. Astronomers study faraway planets like this by watching how their light changes when they pass in front of their star. This allows us to figure out what kinds of gases are in the planet's atmosphere. Back in 2013, the James Webb Space Telescope found methane and carbon dioxide in the atmosphere of the planet. These are carbon-based molecules, and it was the first time they were found on a planet in the habitable zone. Scientists also saw a weak signal of a chemical called DMS, which is mostly made by tiny ocean life here on Earth. So, the researchers pointed the telescope at the planet again a year later using a different tool that could pick up more light details. This time, they found much stronger signs of DMS and some related chemicals. But the problem is the signals aren't strong enough yet. They haven't reached something called the 5 sigma level, a parameter scientists use to confirm discoveries. Plus, even if the DMS really is there, it doesn't automatically equal the existence of life. Scientists once found DMS on a comet, which means that it can be produced without some kind of life taking part in the process. And still, the amount of DMS on K2-18b looks way higher than anything seen on Earth. That's why some astronomers are sure it's coming from something living. K2-18b has been a top pick for what scientists call a Martian planet. This term means a big, watery world with thick hydrogen atmosphere. It's not the kind of place where extraterrestrial civilizations like in movies would live. But it could be home to tiny life forms, like the microbes that once lived in Earth's oceans billions of years ago. Once again, not everyone agrees on how friendly K2-18b really is for life. Some scientists think planets like this might actually be too close to their stars to hold on to liquid water. K2-18b orbits its star every 33 days, which is pretty fast, and could mean it's too hot. That's why some experts claim that even if the planet has any water at all, it might be boiling. Or maybe it's not water, but oceans of lava. But most scientists agree on one thing: we should wait and see. With just 16 to 24 more hours of telescope time, astronomers could confirm what they've seen. This could happen in the next few years, and even if it turns out K2-18b isn't the world we're looking for, we're still getting close. With powerful telescopes like James Webb and more coming in the future, we might be able to answer whether we're alone in the universe or not. At the same time, some places in our own solar system, like Mars, Venus, or Saturn's moon Enceladus, might actually have a better shot at hosting life. Or we could keep exploring other promising worlds, like Proxima Centauri b, which is the closest exoplanet we know about. It's just 4.25 light-years away from us and orbits a small star called Proxima Centauri, right in the habitable zone. This planet is a bit bigger than Earth, which makes it a super-Earth. That's what we call exoplanets larger than ours, but much smaller than gas giants like Neptune or Jupiter. Proxima Centauri b is a fast-moving world. It needs a mere 11 days to go all the way around its star. Scientists think Proxima Centauri b might have a rocky surface, and that's a good sign for possible life. On the other hand, its star blasts it with a lot of ultraviolet radiation. It might have already destroyed the planet's atmosphere, if there was any to begin with. So there's a big question mark when it comes to this world's habitability. Then we've got TRAPPIST-1e, another promising Earth-like planet. It's one of 7 rocky planets orbiting a small, cool star called TRAPPIST-1, about 39 light-years away. Discovered in 2017, it might be one of the most promising places to look for life beyond Earth. This planet is actually a bit smaller than Earth, with a mass around 1/2 that of our planet. It completes an orbit around its star in just 6 days, which is super fast compared to Earth's 365 days. The planet's size and density suggests it has a rocky surface, and that's another key factor when we talk about habitability. Even though TRAPPIST-1e is very close to its star, the star is quite dim and cool, so the planet might still have a stable Earth-like climate. Some scientists even think it could have more water than Earth. Let's move on to Kepler 186f, located about 500 light-years away. It was the first Earth-sized planet found in a habitable zone of another star. It orbits a red dwarf, which burns cooler and lives much longer than our Sun. This means Kepler 186f could have stable conditions for billions of years, giving life plenty of time to possibly form and evolve. The planet gets only about 1/3 of the sunlight Earth receives, so it would likely be cooler but still warm enough to keep water from freezing. It also seems to be a rocky planet just like Earth, which boosts its chance of hosting life. Now, how about visiting LHS 1140b, about 40 light-years away? This planet has about 5.5 times the mass of Earth. Scientists think it's rocky and possibly has a thick atmosphere, which is a big deal. An atmosphere like that can trap heat, keep temperature stable, and protect water from escaping into space. This world orbits a quiet red dwarf star, so it's not constantly blasted by harmful flares like some other exoplanets are. Some studies even suggest LHS 1140b could be an ocean world with lots of water. So it's one of the more exciting planets we've found in our neighborhood. And finally, we have Gliese 12b. Astronomers call it Exo-Venus. It sits 40 light-years away from Earth. This world is about the size of Venus and orbits a cool red dwarf star. It needs just under 13 days to complete one orbit. The temperature on the planet is around 107 degrees, which is quite warm but still okay for life. The thing that makes Gliese 12b so interesting is that it could help us understand how Earth-sized planets around cool stars hold on to their atmospheres. That's important because an atmosphere is crucial for things like liquid water and protecting life from harmful radiation. According to some researchers, Gliese 12b is one of the best chances we have to figure out whether planets like this can stay habitable.
It's dark and incredibly cold. There's no oxygen, there's no water, there's no life. But the James Webb Space Telescope doesn't seem bothered by all this. Its main goal is to find the very first galaxies that formed billions of years ago in the early universe and observe the stars making up distant planetary systems. Its mission is to… but wait, what is that? The James Webb Space Telescope has discovered something absolutely amazing, a star-planet hybrid with very strange clouds. This bizarre world, called VHS 1256b, is actually a brown dwarf. Those are bigger than planets, but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf we're talking about is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars. And to complete one orbit, the brown dwarf needs 17,000 years. In fact, astronomers found out about this unusual exoplanet in 2016. But at that time, they didn't classify it as a brown dwarf, and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Scientists have been putting forward theories about the existence of such sand clouds on exoplanets for quite some time. But the discovery the James Webb Space Telescope made is the first real proof. The silicate particles on the sandy dwarf are most likely quartz or some other mineral. In size, they're less than a micron, and 1 micron is 1/25 of a thousandth of an inch. In other words, they look like particles in smog. The exoplanet seems to have an atmosphere which contains some water, methane, and other substances and minerals. Interestingly, this atmosphere isn't still. It's constantly undergoing extreme changes. Another cool thing about it, scientists have detected carbon dioxide. And this is only the second confirmed discovery of this gas on a planet outside of the solar system. By the way, the James Webb Space Telescope, with the help of which astronomers discovered our sandy brown dwarf, is an absolutely stunning piece of equipment, around 100 times more powerful than Hubble. Even though the telescope itself is 3 stories high and its size equals that of a tennis court, its mirrors are the lightest large telescope mirrors of all time. When all the 18 mirrors of the telescope were completed during the manufacturing process, their mass was reduced by 92% in comparison to the initial discs. Each mirror weighed a mere 44 Aliyah-bas. The telescope's mirrors seem to be gold, but in reality, they're made of beryllium, steel gray, lightweight, and brittle metal. There's indeed a gold coating on each mirror. But they can't be produced entirely out of gold, since this material tends to expand and contract even with small temperature changes. That's why the total amount of gold in the James Webb Space Telescope is less than 2 ounces. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than 370 F. That's cool enough to make nitrogen liquid. A truly enormous 5-layered sun shield stretches around the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. The telescope orbits the sun more than 1 million miles away from Earth, and when it runs out of fuel, it'll keep orbiting the sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its life. Anyway, If you think that our newly found brown dwarf is the only bizarre exoplanet out there, let me show you some other breathtaking worlds. There is an exoplanet that is really something else. Just look at its awesome magenta color. You can find it in the Virgo constellation. The planet is called Gliese 504b. It orbits very far from its parent star, 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. One of the oldest exoplanets we know about, PSR B20-26b, is about 12.7 billion years old. It's almost 3 times as old as Earth. This also means that the so-called Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white dwarf and a pulsar making almost 100 revolutions per second. I bet sunrises on this planet must look awesome. Just 20 light years away from the Sun, which isn't such a great distance when we talk about space. A bizarre rogue planet is roaming the Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's. The exoplanet also produces amazing auroras. That's why when it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf. But later, scientists got some proof that this space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet in the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create mesmerizing light shows. The next exoplanet isn't like any other. It's often called Super Saturn or Saturn on steroids. That's because J147b has a colossal system of rings. They're 640 times as large as those our Saturn has. This bizarre world is the only planet we know about that has rings similar to Saturn's. If you moved this giant to our solar system and used it to replace Saturn, its rings would look many times larger than a full moon. An exoplanet called WASP-12b munches on the light coming from its star. It's one of the darkest worlds people know about, all because its day side consumes light rather than reflects it back into space. The egg-shaped planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. It might be the main reason for the temperatures on the surface of the planet that can rise up to 4,600 staff. The night side of the planet isn't as hot as its day side, a mere 2,200 giraffe. The difference in temperature makes water vapor and clouds gather above the surface of the planet, and from time to time, swirls of material from the planet's superheated atmosphere spill onto its star. What a view! Discovered in 2017, Kelt 9b is one of the hottest exoplanets we know of. The temperatures there can reach 7,800 AOS. For comparison, the temperatures at the surface of the Sun reach 10,000. The planet is probably so insanely hot because it orbits extremely close to its star, Kelt 9, which is way hotter and bigger than our Sun. Experts believe that the giant star might one day evaporate the entire planet. Colonizing other planets is like the ultimate cosmic adventure. It's a challenge that has captured the imagination of humans for centuries, and it's something that we've always dreamed of doing. One of the most popular candidates for this role is Mars. And this isn't surprising. Mars is a rocky planet that is similar to Earth in many ways, and it even has evidence of water on its surface. This makes it a prime candidate for human colonization. Many scientists and engineers are working on plans to send humans to Mars and establish a permanent settlement there. But what about the other candidates? There are many planets and moons in our solar system, so why not colonize something else? For example, Ceres? Ceres is the ultimate cosmic treasure trove. It's a dwarf planet, not a full-fledged one, just like Pluto. It's located in the asteroid belt between Mars and Jupiter. This dwarf planet is the closest to the Sun, and it's adorably tiny. The entire planet is about the same size as the state of Texas. So why choose it? Because Ceres may be a rich source of valuable resources. The surface of Ceres is covered in craters and other geological features, and scientists believe that beneath its surface, it has a thick layer of water ice, which means that deep underground it may have an ocean of liquid water. If this is true, Ceres could be a valuable resource for future space missions. It could potentially provide a source of water for human exploration of the solar system. So, can we colonize it? And if so, how do we do that? Actually, many scientists and space enthusiasts have proposed this idea. To colonize Ceres, we'd have to use the same methods used to establish colonies on the Moon, Mercury, and the satellites of Jupiter and Saturn. Don't worry, it's not that hard. We just need to figure out how to adapt to a very thin atmosphere, to extreme temperatures and pressure and all the other nasty stuff. But let's stay hopeful. At the end of the day, it all comes down to resources. We'll need water, minerals, silica, and other raw materials. All this would help us to create a self-sufficient colony. And luckily, Ceres is full of these things. So first of all, we could locate the places of residence inside the craters of Ceres. We could build domes there that would protect us from all sorts of dangerous things, like radiation. We could also mine regolith in the asteroid belt. Regolith is a residual soil that appears as a result of cosmic weathering of the rock. Basically, it's something like the surface layer of soil on the Moon. Why do we need it? Well, because we could use it to 3D print the base layers next to the ice, so that our bases would be located near the water. We could then use these base layers to print other structures, like houses. We could also collect ice and organic molecules to create water, and by combining water with regolith, we would get soil in which we could grow plants and food. Wonderful. There's also another option. A colony can be created underground, that is, right next to the icy crust of the planet. Now, if in the future we'll be some kind of super cool scientists, we could try to accelerate the rotation of Ceres, which sounds crazy, but would be pretty beneficial. It would help us to create artificial gravity inside the underground colonies. And speaking of gravity, all of these things may sound cool, but let's discuss the difficulties that lie ahead of us during colonization. To colonize Ceres, we would need to overcome a number of challenges. To begin with, we need to develop technologies that will help us even get to Ceres. We need some kind of ships that would be capable of long flights into deep space. For them, first we need to create some kind of nuclear thermal or nuclear electric traction, and maybe an even more advanced type of fuel. Then we'll also need technology to help us sustain life in this small, rocky world. That is, tools to extract and use local resources. Also, since there is no atmosphere on Ceres, we would have to wear spacesuits and live in pressurized habitats. And this is only the beginning. Living on the planet itself won't be an easy task either. For example, what about extreme temperatures, or radiation, or the mentioned incredibly weak gravity? The latter is definitely one of the biggest problems. The gravity of Ceres is only 3% of the Earth's. You wouldn't want to accidentally fly into outer space while playing football, would you? But the fact that any jump could send you on an endless journey isn't the only problem. Even if you somehow stay on the surface of the planet, you'll experience the same symptoms and problems as astronauts who hang out on the International Space Station. For example, loss of muscle mass, decrease in bone density, deterioration of vision, problems with the cardiovascular system. Wow, who would have thought that gravity is so important? So therefore, if we wanted to survive on Ceres, we would need either a bunch of doctors or some kind of artificial gravity. And don't even get me started on how low gravity will slow down production and work. And of course, we can't go anywhere without discussing money. Colonizing Ceres will cost us a huge expense, especially taking into account all of the above. And yet, despite all these things, Ceres still stays one of the best candidates for colonization. For example, Ceres contains lots of methane and ammonia. They can be used as a manufactured fuel or a nitrogenous gas, or you can just mine it there in order to colonize Mars and Venus. Even low gravity has its advantages. Thanks to it, it will be very easy to launch spacecraft from Ceres. We'll waste much less fuel, which means that transportation from Ceres to other planets would be much cheaper and more efficient. So even if Ceres doesn't become our permanent residence, it can become a good transport hub, something like a spaceport. We could use it as a base for mining all sorts of useful things from the asteroid belt. Then, we could transport all these resources back to Mars or Earth, and it can also become a refueling station for ships traveling further beyond the solar system. Sounds cool and pretty sci-fi-ish, doesn't it? But it seems that any attempts to create a permanent base in the asteroid belt will have to wait. Colonizing other planets is a difficult and complex task. It will require the cooperation and expertise of many different people, and it will involve developing new technologies and overcoming many challenges. Before we go to Ceres, we need to build infrastructures on the Moon, Mars, and somewhere in between. Otherwise, any attempts to colonize it would be prohibitively expensive and would most likely fail before future missions could even reach it. But the more colonies we create, the more likely it is that sooner or later we'll build another one on Ceres. This would not only open the asteroid belt to economic exploitation, it would also serve as a stepping stone to the outer solar system. This, in turn, could lead to colonizing the moons of Jupiter and beyond. In other words, the rewards of colonizing Ceres could be great. Not only would it allow us to explore and understand this fascinating world, but it could also provide us with valuable resources that could help us to further explore and settle the solar system. Life on Ceres would likely be challenging, but exciting, as humans would be making a new home for themselves and exploring the mysteries of the universe. Just imagine all the new planet-themed restaurants and shops we could have. Welcome to Ceres Mart, where everything is out of this world. So if you're a fan of cosmic treasure hunts, Ceres is surely a rich and rewarding destination. Just make sure you bring some weights on your feet so you don't fly anywhere.
Way out by Saturn, there's an icy moon called Enceladus. And it's literally spitting out ice into space. And that ice contains the stuff life's made of. Oh, and there's a whole ocean hiding under the ice. And who knows what's living in it. Enceladus is only about 300 miles across. It could literally fit inside the state of Colorado. But even though it's super small, it's got liquid water, energy from hydrothermal vents, and a bunch of chemicals that could actually support life. In other words, it's one of the best spots in the solar system where life could exist. Now, rewind about 20 years. NASA's Cassini spacecraft flew by Saturn and noticed something strange. Enceladus was shooting out little jets of icy particles from cracks near its south pole. Later, scientists realized those jets were coming from a giant underground ocean beneath the moon's surface.
When they analyzed the frozen grains from those plumes, they found almost all the elements needed for life: carbon, hydrogen, nitrogen, oxygen, and phosphorus. Only sulfur was missing. The only problem was, most of those samples came from Saturn's E-ring, a huge ring made of dust and ice that surrounds the planet. And those particles had been sitting out there for decades, maybe centuries, meaning they could have been changed by space radiation. So no one could say for sure if those life ingredients really came from Enceladus itself. But now that's changed. A new study has just confirmed that fresh ice grains, the ones newly blasted out from Enceladus, contain organic molecules, including stuff like nitrogen and oxygen. Here's how scientists figured it out. In 2008, Cassini flew right through one of those icy geysers, and it literally got splattered with tiny particles. They hit the spacecraft's dust detector at insane speed, 11 miles per second. That's fast enough to separate all the molecules, so the team could see what they were really made of. Then the scientists used a technique called mass spectrometry and managed to study those fresh grains in detail. They found molecules that on Earth are part of certain chemical reactions. Those build the complex structures life needs to exist, including ones that may contain nitrogen and oxygen.
One of the researchers said that this likely proved that those complex organic molecules hadn't formed in space. They might have actually been coming straight from Enceladus's ocean. Another scientist explained that those molecules could play an important role in biological processes. All this means that Enceladus might really be habitable. But even if there's no life there, that's still a big deal. Because then we have the right to ask, wait, why isn't there life when all the right conditions are in place? The story doesn't end there. The European Space Agency is already planning a future mission to actually land on Enceladus, right at its south pole. They want to scoop up more samples and see what's really going on under all that ice. The launch is planned for sometime in the early 2040s, so in just a few decades, we might finally find out whether this tiny frozen moon is home to some bizarre life forms. But Enceladus isn't the only potentially habitable place we know about. Admittedly, the others are beyond the edge of our solar system. Like 3 possible super-Earth planets orbiting a nearby orange dwarf star. Now, super-Earth is just what scientists call planets that are bigger than Earth but smaller than the icy giants like Uranus and Neptune. Scientists from the University of Exeter found that those exoplanets were orbiting their parent star, HD 48498, which sits about 55 light-years away from Earth. That's practically our cosmic neighborhood. Each of these planets takes a different amount of time to go around its star. One needs 7 Earth days, another 38 days, and the last one 151 days. And the coolest thing is that the outermost planet might actually be hanging out in the star's habitable zone. That's the sweet spot where it's not too hot and not too cold for liquid water to exist. It means the planet's surface could be comfortable enough for water to exist without boiling or freezing. This makes it a great candidate for life as we know it. Over 10 years, the team collected nearly 190 super precise measurements using cutting-edge equipment that looks at the light coming from stars. By checking whether the star's light is slightly shifting toward us, this is called blue shift, or away from us, that's red shift, they can figure out if a planet is tugging on it. The host star itself is an orange dwarf, something like our Sun's smaller and calmer cousin. It's similar to the Sun in many ways, but as an orange dwarf, it gives off less radiation than our yellow dwarf star does. The coolest part is that this is one of the closest planetary systems we've ever found that hosts a super-Earth in the habitable zone around a Sun-like star. Now, super-Earths aren't exactly rare. Scientists have found over 6,000 exoplanets since the first one orbiting a Sun-like star was confirmed in 1995. To spot such distant worlds, astronomers use all sorts of tools, like NASA's Kepler telescope, launched in 2009 to find Earth-like planets in the Milky Way. Let's sneak a peek at some of the most exciting exoplanets out there. Gliese 667 cc is only 22 light-years away, even though that's still about 129 trillion miles from us. It's about 3.8 times the mass of Earth, and zips around its red dwarf star in just 28 days. So a year there is 13 times shorter than ours. Its red dwarf star is cooler, and the planet probably sits in the habitable zone, though occasional stellar flares could give it a sunburn. Kepler 22b is way farther out at 600+ light-years. It was the first Kepler planet found in a habitable zone. It's about 2.4 times bigger than Earth, and we still don't know if it's rocky, liquid, or gaseous. Its orbit is close to Earth's, taking 290 days to circle its G-class star, smaller and colder than our Sun. Kepler 69c is a whopping 2,700 light-years away. This planet is almost 70% larger than Earth. Its orbit takes 242 days, putting it in a Venus-like spot in its system. But since its star is only 80% as luminous as our Sun, the conditions on that planet might be way friendlier than those on Venus. We discovered TOI 733b in 2023. This world is about 245 light-years away. It orbits its star super fast, taking just 4.9 Earth days. But the coolest thing is that it might be completely covered by a massive ocean. Could there be life in that ocean? Time will tell. GJ 1214b is 40 light-years away, pretty close by space terms. The planet is almost 3 times Earth's diameter and 8 times as heavy. It needs 38 hours to orbit its red dwarf star. The surface temperatures there hit 450 degrees Fahrenheit, and with all that heat and pressure, water behaves in crazy ways, like hot ice or superfluid water. By the way, that superfluidity is wild stuff when water moves like magic without friction. But don't try it on Earth. You'll just get dehydrated. Proxima Centauri b is the closest super-Earth, sitting at just 4 light-years away. It has a similar mass to Earth's, but a year there is only 11.2 days. Its star even wobbles a bit thanks to the planet's gravity. That's actually how scientists discovered it. The planet sits in the habitable zone but gets blasted by extreme UV radiation because it's super close to its star. Right now we can't even study its atmosphere. And finally, TOI 715b. This one orbits a red dwarf, which is smaller and cooler than our Sun. These tiny stars are pretty great for finding habitable worlds because planets can orbit close without frying. TOI 715b may have once had a super thick atmosphere like Neptune's, but it might now be losing it. Scientists need more research to see if it's now a watery, rocky world. In any case, some of these planets might have oceans, some might be way too hot, and some could even be our distant cosmic cousins. Either way, each discovery helps us understand the universe a little better. And who knows, maybe someday we'll even set foot on one of those super-Earths.
Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth, but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star, and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun, but since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions. There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a Sun-like star in 1995. To find those distant planets, astronomers use different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, it's still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler 22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth, it's about 2.4 times our planet size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler 69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on the super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and it's called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet.